This presentation introduces a new model to describe Dutch sentence intonation. One of the first experimental analyses of Dutch sentence intonation was reported by Hart, Collier, and Cohen about 50 years ago. They brought to light a characteristic hat pattern for the fundamental frequency curve. Later, in the wave of the autosegmental metrical approach applied to prosodic events, prosodic descriptions based on the acoustic analysis of sentences led to the development of the intonation transcription system TODI, a variant of the well-known TOBI system originally proposed for American English. The purpose of these studies was to establish a grammar of Dutch intonation, a grammar resulting from a collection of well-formed intonative prosodic events transcribed with the TODI notation. Such grammar assumes that minimal prosodic units are accent phrases containing only one non-emphatic stretched syllable. In the autosegmental metrical view, prosodic events located on stretched syllables, one per accent phrase, are called pitch accents. Those located on intonation phrases, left and right boundaries, are called boundary tones. In this model, and this is very important, pitch accents do not interact with each other, so that the prosodic structure is actually defined by boundary tones. Furthermore, according to Gussenhoven, there is no intermediate intonation phrase in Dutch that would assemble accent phrase in an intermediate level of the prosodic structure. Starting with the same definition of accent phrases as minimal prosodic units, the prosodic structure in this proposed model is defined as a hierarchical assembly of accent phrases into multiple levels, not just one level. In this accent phrase hierarchy forming the sentence prosodic structure, only intonation phrases are possibly indicated by boundary tones. The other levels in the structure are marked by specific pitch accents, possibly acting together with boundary tones at the IP level. In this view, pitch accents do interact with each other, depending on the prosodic structure complexity in terms of levels and in terms of number of accent phrases merged together at each level. Another important difference pertains to the transcription of prosodic events, and particularly of pitch accents and boundary tones. Instead of considering tone targets as in the TODI system used in the autosegmental metrical model, pitch events are transcribed as melodic contours characterized by a perception criterion based on their glissando value. Glissando value is a parameter that integrates perception into description of the melodic contours. Actually, glissando are compared to a threshold of glissando threshold, which defines the level above or under which a change in fundamental frequency is perceived as a change versus perceived as a static tone. So, using melodic contours rather than tonal targets, classes of melodic contours are defined from the melodic movement located on the accent phrase stressed vowel. And it goes as follows. First, we have the terminal conclusive declarative, which is falling and reaching the lowest pitch value in the sentence, usually above the glissando threshold. There is a counterpart interrogative, which is then rising and reaching the highest pitch level in the sentence, and again above the glissando threshold. Then we have the rising contour, which has a rate of frequency change above the glissando threshold. There is a counterpart falling, a falling contour, again with a change in frequency above the glissando threshold. The next class is the neutralized contour, which can be rising and falling, but the rate of change in frequency is below the glissando threshold. And finally, we have the complex contour, which has two parts, falling on the stressed vowel of the accent phrase and rising on the final vowel of the accent phrase. And usually the complex contour is followed by a pause. From these classes of contours, we define dependency relations between accent phrases. These dependency relations determine hierarchical grouping of accent phrases and ultimately determine the sentence prosodic structure. So you can see that each contour or class of contour is color-coded, the neutral contour in brown, the rising contour above the glissando threshold in blue, the falling contour again above the glissando threshold in green, the complex contour in light blue, and the declarative terminal contour in red. So you see that these dependency relations function from left to right. In other words, for instance, the rising contour in blue, the second line here, is dependent towards some falling or complex or terminal declarative contour on its right. That means later in the sentence. There's one different relationship of dependency relation between contours that goes from right to left, and this is on the third line, which tells us that the falling contour above the glissando threshold is dependent on the rising contour, but this time situated on its left. That means earlier in the sentence, and we'll see examples showing these different mechanisms and dependency relations which define the prosodic structure. The analyzed corpus consists of recordings sampled at random from a set of about 565 read sentences, part of the corpus of gesproken Nederlands for the Dutch variety. Read sentences were selected according to their apparent increasing complexity based on the number of words and therefore of accent phrases they contain. Acoustic analysis was carried out with the speech analysis software WinPitch, which is a software dedicated to fundamental frequency analysis. It was judged preferable to the de facto standard PRAT for its prosodic graphic annotation functions and much better fundamental frequency tracking capabilities, among other features. In WinPitch, graphical commands allow to draw linear segments to approximate sections of fundamental frequency corresponding to the accent phrase stressed and intonation phrase vowels. These segments are automatically labeled and color-coded according to the definition of melodic contours given earlier. The two first examples here are very simple because they show only a prosodic structure involving two accent phrases. And you can see on the left a rising contour in blue. Blue means it's a class of contour above the glissando threshold and rising, which defines a dependency relation towards a final conclusive declarative contour, which is color-coded in red here. So the rule here is shown on the top of this right arrow, which defines the simple structure with only two accent phrases. And we can listen to it.
Een man als een schaduw.
Okay. On the right side, it is something similar, but this time it's a neutral contour in brown, which defines dependency relation towards a final conclusive contour. So you see, in both cases, the prosodic structure is extremely simple. Let's hear the example.
Zijn hoofd bonkt.
The next example shows us a prosodic structure with three accent phrases, and you can see that this time two different dependency rules apply. The first one shows a dependency of the neutral contour towards a rising contour in blue, rising contour again above the glissando threshold, and the next rule implies the rising contour depending on a declarative final terminal contour. And we can listen to the example.
Een fietsbel rinkelt in de avondschemering.
The next example shows us two occurrences of a rise-fall pattern, and you can see that the rule going from right to left this time, telling us that there is a dependency relation between a falling contour above the glissando threshold, encoded here in green, towards a rising contour, again above the glissando threshold, encoded in blue, and situated on its left. So this time it goes from right to left. And this rule applies twice on these four first contours. And the two rising contours in blue are depending on something happening on the right later in the sentence, which is in this instance a complex contour. So you can see the rule that it's applied here, it's rising depending on a complex contour. And we can now listen to the example.
Hij had nog maar een paar minuten gelopen.
This example is a bit more complex. As you can see, at the beginning of the sentence, we have three accent phrases, and they imply a rise-fall pattern, but this time with a neutral contour in between the two extreme contour of this pattern. So you can see how the rules apply. The neutral is depending on the occurrence of a falling contour above the glissando threshold located on its right, but this falling contour depends on a rising contour above the glissando threshold, but located on its left. So it gives you this pattern which defines the prosodic structure. And on the right side of the figure, you can see how two neutral contours depend on a complex contour located on their right. And we again listen to the example.
Een ascetische Joodse groep die zich de Therapeutei noemde.
Again.
Een ascetische Joodse groep die zich de Therapeutei noemde.
This example presents three intonation phrases. The two first ended by a complex contour, and the last one ended by a terminal conclusive contour, color-coded in red.
Er zijn zoveel verschillende manieren om kipfilets te bereiden, dat ze probleemloos meerdere keren per week op het menu kunnen staan, zonder dat ze eentonig of voorspelbaar worden.
The last example will be played twice, first at normal speed, then at a slower speed.
Een ascetische Joodse groep die zich de Therapeutei noemde, en die we ook uit de geschriften van Philo kennen, is mogelijk van invloed geweest op de vroeg-christelijke kluizenaars en monniken. Een ascetische Joodse groep die zich de Therapeutei noemde, en die we ook uit de geschriften van Philo kennen, is mogelijk van invloed geweest op de vroeg-christelijke kluizenaars en monniken.
There are some obvious points of discussions here. First of all, melodic contours are aligned on stressed vowels, but sometimes are we really sure that syllables known to be stressable are effectively stressed? And this is frequently the case with compound words, such as kipfilets. Is it kipfilets or kipfilets? Same with avondschemering. Is it avondschemering or avondschemering? So another point is the glissando threshold. The way it's computed, it's an approximation. Sometimes the melodic curve is not really linear. So we approximate it with a linear change in order to compute the glissando threshold. And furthermore, the formula giving us the threshold has a coefficient that varies in the literature between 0.16 and 0.30. So this brings some uncertainty about the classes of melodic contours related to the fundamental frequency changes. Other than that, the role of accent, phrase, pitch, accent as marker of intonation, phrase, substructure appears more clearly once they are described not as tone targets, but are melodic contours. So we come to a conclusion in 3 points. First of all, prosodic events located on stress vowels are described by melodic contours characterized by their glissando value and not by tonal targets, and this seems more effective in describing the prosodic structure. Point 2 is the fact that melodic contours define dependency relations between accent phrases, leading to a grammar involving prosodic structures with more than one level. And thirdly, this model provides coherent explanation for melodic contour neutralization in the framework of a prosodic grammar involving dependency relations a priori independent from syntax. And finally, the list of references as follows.